Hello, I'm Jon. I'm the CEO of Veridise, and today I'm going to talk to you about AuditHub, which is a new security platform that we created for Web3. So basically where I want to start is by talking about the software security lifecycle. So essentially, when we look at the software security lifecycle, we can see that development is often performed in several distinct phases. And so first, someone will plan their project, then they'll go and perform all the development. After that, they usually do end-to-end testing, followed by auditing and deployment. And so one thing that we can see here is that security often isn't considered until, the testing and auditing phases. And so that means that really, you're not looking at security until the very end of development. And on top of that, the internal proactive security is only being performed at the very end. And then it's kind of left up to the community after deployment when someone, tries or lists their services on a bug bounty platform or something like that. And so really what we want to ask is, what is the problem with this? Well, we can see that even with audits, a substantial amount of money is being lost due to smart contract exploits. So for example, in 2024, about $350 million of funds were lost due to smart contract exploits, and almost a third of them were audited. And so that means that even projects that are getting audited and the exploit is in scope, you're not always finding those bugs. In addition to that, we see that critical code is often excluded from an audit. And what I mean by that is, it's not uncommon for projects to modify their code base after an audit or to leave certain critical parts of their code base out of scope. And this led to another $80 million worth of losses in 2024. But in 2025, it got even worse, where $223 million was lost due to a single hack from an out-of-scope math library. Then, if we go and look at ZK, things get kind of worse. So we might not have a whole lot of ZK in the marketplace right now, but at Veridise we've performed a lot of ZK audits, and so they're coming. But one thing that we saw when we did a study of our ZK audits was that 55% of the projects that we audited had at least one critical vulnerability. And then when we compared that to DeFi projects, we saw that this was twice as likely to have a vulnerability, or a ZK project was twice as likely to have a vulnerability as a DeFi project, which means that these ZK integrations are often security critical because they bring things like scalability or privacy, but development is very error prone. And so really, the problem that we see here is auditing is expensive, which has caused projects to deploy unaudited and leave critical code out of scope. In addition to that, there's this kind of attitude that if I get an audit, then it will report all of the bugs. But audits are intended to, yes, report bugs, but not the absence of those bugs. And so you can't guarantee that an audit has found everything. And in addition to that, we've seen that this kind of security last approach really limits the flexibility of a project. And what I mean by that is, at Veridise, when we find these critical bugs, it's often the case that, someone has a deployment date in mind and they're shooting for that deployment date. And so when a critical bug needs to be fixed, someone has to go and try to rush through the implementation, which can lead to delays, re-audits, and then in other cases, it can lead to features being left out from the deployment. And so this is kind of the problem that we're looking at right now. So what do we do to fix it? Well, there's a couple of possible things that we can do. So we can evaluate these based off of a couple of metrics divided between usability metrics, which are metrics that are desirable to developers, and security metrics, which are important for providing more security. And so if we look at the metrics that are important to developers, we're looking at things like they want affordability. You want something that's low effort, something that the developer doesn't really have to, constantly interact with, and something that's on demand. In addition to that, from a security perspective, it's useful to have something that's tailored to your project, which means that it's looking at the custom business logic in your project and that has security guarantees. So what I mean by that is if I report a bug, then that means it's definitely a bug. Or that if I don't report a bug, then it's definitely not there. And so now we can look at some of the suggestions that people have made in order to see whether or not they're a good fit. So one thing that we can look at is auditing. Projects could possibly get more audits. The problem that we have is when it comes to auditing, they are low effort on behalf of the developer, and they are customized to the business logic of the project. However, they're not super affordable, as we already mentioned, and they don't really happen on demand. Even if you are able to get an audit right away, you have to wait weeks, usually, in order to get an audit report. In addition to that, audits come with no security guarantees. So in order to try to address some of these issues, people have suggested AI auditing. So the nice thing about AI auditing is it comes with, additional affordability. So that means that, if you have a subscription to ChatGPT or something like that, you can perform AI auditing. And the nice thing is it can happen on demand because you just query your model. The problem with AI auditing is it doesn't come with any security guarantees, though. And so what I mean by that is through studies that we've done at Veridise, as well as studies that we've seen other people perform on using AI for security, they're good at finding more surface-level bugs. And what I mean by that is they're good at finding common vulnerabilities that they've seen in the past and in a form that they've seen in the past. So deeper logical vulnerabilities, they're not very good at finding, and they're not good at finding common vulnerabilities that don't look similar to what they had in their training set. So now we can go and look at something else. So we can look at security tools. So these have been available in the market for a while, and really the perception that a lot of people have of security tools is that they're not very low effort. So if you look at something like a static analyzer, when you get reports from a static analyzer, you have to figure out which of those actually correspond to actual vulnerabilities, which if there's a lot of reports, that can take a while. In addition to that, for fuzzing and formal verification, you have to provide information about the behavior of the system, which again, is more work that lands on the developer. If we look at formal verification as well, there's often also a stigma that formal verification requires experts in order to perform it, and so that means that really it doesn't happen on demand because you have to find such an expert and then wait for them to actually perform the formal verification. But the nice thing is, most of the time, it does come with security guarantees. And so really what I want to ask is the part about security tools correct? So this is where I want to talk about AuditHub, which is a security platform that we at Veridise introduced right before TOKEN2049. So what we've integrated into AuditHub is several security tools. And so AuditHub has tools for both smart contracts and for ZK circuits. And specifically on the smart contract side of things, we have static analyzers and fuzzers. And on the ZK side of things, we've got static analyzers and a formal verification engine. So let's look and see what AuditHub can do. Well, one thing that we wanted to do is we wanted to be able to find common vulnerabilities. So the nice thing about common vulnerabilities is they don't require any additional input, and they can look for things that actually kind of have an impact and that we've seen repeated time and time again. So for example, in 2024, we found at least $120 million worth of hacks came from exploiting common vulnerabilities like reentrancies in the smart contract domain. In addition to that, if we look at ZK, a study found that about 95% of the critical vulnerabilities in a ZK circuit came from a single type of issue, which is a circuit or the constraints of a circuit being non-deterministic. And so what this means is we can tailor our projects to look for these common vulnerabilities without requiring any additional input from the user. And so at Veridise, that's exactly what we did. So Vanguard and ZK Vanguard, which are two of our static analyzers, can look for common vulnerabilities in smart contracts and ZK circuits. In addition to that, though, we made sure our other tools could look for common vulnerabilities. So OrCa, which is our fuzzer, can look for violations of common invariants in different types of projects, but just by knowing that this is a token, this is a lending pool, and so on. And then Picus, which is our formal verifier for ZK circuits, can automatically verify whether or not a circuit is deterministic because it's a very well-defined property, and it doesn't require any additional input from the user. However, even with finding common vulnerabilities, we also need to look at vulnerabilities that are specific to the business logic of the particular project. And so this is why we need to be able to tailor security tools for a particular project. And more specifically, in 2024, we saw that about $130 million was lost due to exploiting the business logic of a particular project. And so for this reason, most of the security tools that we're building at Veridise can also be customized. You can provide them with additional information about the project, and it can look for violations of properties that you provided them. So for example, with Vanguard and ZK Vanguard, which are static analyzers, we provided the ability to write custom detectors. So that means that they can look for custom errors that are being specified. In addition to that, OrCa, which is the fuzzer that we developed for smart contracts, allows the users to provide custom invariants that it will attempt to violate. In addition to that, we've tried very hard to make all of these tools usable. And so for that reason, we introduced features such as the guided issue triage feature, which basically, in cases where there could be false positives, will allow the user to provide a bit of information about why something is a false positive, and any issue that that was raised for a similar reason is eliminated. So this means that rather than having to go through issues one by one, if you provide this additional feedback, like this is not a vulnerability for X reason, then we can now drill down into the actual vulnerability set a lot faster so that you don't have to go through all of those false positives. In addition to that, because all of these tools are integrated into a unified framework, you don't have to perform setup for each individual tool, which means that if you want to run the fuzzer and a static analyzer, you don't need to go and perform separate setup for each. In addition to those features, we've also provided the ability to integrate these tools into your CI/CD. So this means that after configuring AuditHub, you can go and integrate all of these security-related scans and stuff like that into your CI/CD so that you don't have to go and initiate the security process yourself. Basically, as you push code, as you create PRs and stuff like that, you have security already integrated because that code will be sent to AuditHub and it will try to identify any security-related issues and it will provide that feedback directly back to you. And then in addition to that, if there's anything that you don't understand or that isn't working quite right, we have experts that are there to support you. So really, when we go and look at that table that I mentioned earlier, the breakdown looks a little bit more like this, where when we look at these different types of tools, because we can provide, or we can use the tools without relying on any input from the developer, they become low effort. In addition to that, all of them can happen on demand. So for example, Picus, which is our formal verification engine, was able to verify Ketchik's, or RISC-Zero's Ketchik ZK circuit in under 8 minutes. In addition to that, almost all of the tools can be tailored to a specific project, and they all come with security guarantees, which means that you can provide more confidence of the correctness of the project. So how does this help? Well, basically, security can be integrated more tightly in the development process. So after performing the initial planning and deciding on the tech stack, you can just basically run the tools or get the tools set up so that they can look for common vulnerabilities in that tech stack. Then, as you continue to develop, you can integrate security evaluations into the development process by tailoring the tools and making sure that any of these vulnerabilities are found early. And so why do we want to do that? Well, because it allows you to fix bugs early before you start building on them. It allows you to include the entire project. No longer do you have to worry about having out-of-scope code. It also allows you to get more frequent security feedback and feedback that's tailored to your project. And finally, it provides security guarantees. So if this sounds helpful to anyone, this is a service that we launched right before Token2049. And so if you're interested in seeing a demo or anything like that, you can talk to me, or there's a QR code with a link to a form. We also have special incentives right now because we just launched the beta of this service. And that's it. Thank you.